As you may remember from last week, the SAT is divided into two sections. The first one is the non-calculator and the second one is the calculator. All of these questions come from the non-calculator portion, which is the first one that you take, 25 minutes long, 20 questions. You'll notice that all of these questions are either like identifying concepts or identifying if a certain equation goes with a graph or a table, or if they do require any calculations, all the calculations can be easily done by hand in a reasonable amount of time. However, this does mean that in order to do well on this section, you will have to remember how to add and subtract two-digit numbers or multi-digit numbers by hand. You'll need to remember how to multiply by hand. You'll also need to remember how to do your long division. So if those are things that are a little fuzzy for you, highly recommend finding some practice for those on Khan Academy, or come see me and I can get you set up. Alright, so put those calculators away and here we go. So the first question on your SAT math practice asked you to match this equation, y equals 2x minus 5, to its graph. Okay, so in order to do that, you're going to have to figure out what the graph of this equation is supposed to look like. You could do that two different ways. You could make a nice little XY chart and plug in x's and figure out y's so that you have points that are on this line. So for example, I could plug in 1 for x, 2 times 1 is 2, minus 5 is negative 3. So I know that the point 1, negative 3 is on the graph of this line, so then I could go through all of my examples and see all my answer options and see which of them has the point 1, negative 3 on it. Okay. My preferred method is actually to look at this as a form of y equals mx plus b, because we go over that quite a bit in our math classes about how slope-intercept form is in this form right here, where y and x are the variables, m is the slope, and b is the y-intercept. So if b is the y-intercept, that means that my equation should start on the y-axis at negative 5. So I'm going to cross off a, because it starts up here at 2.5. This one I'll keep. B is a possibility because it starts at negative 5. C is not a possibility, it starts at 5. And D is a possibility, it starts at negative 5. Okay, so I'm down to B and D. The next thing I know is that my slope is 2, which means the slope is actually 2 over 1 if we think of it as a fraction, which means that for every 2 that we rise, we run 1. Okay, so which of these equations has a rise of 2 and a run of 1? Well, this one actually has a negative 2 rise because it goes down 2 and over 1. This one, it goes up 2, which would be positive 2 and over 1. So I'm going to select D as my correct answer. Our second question is a bit of an algebra question, but it requires you to have some knowledge of how to multiply fractions. Because we're told that if x equals 2/3 y and y equals 18, what is the value of 2x minus 3? Well, this is the question, what is the value of 2x minus 3? But in order to answer that, I'm going to need to figure out what x is. In order to do that, I need to plug y into this equation so that I can figure out what x is. So if I plug 18 in for y, this means that x equals 2/3 times 18. So a good question is, how do I multiply 2/3 times 18 without your calculator, remember? Okay, so remember, to multiply fractions, you have to have both of them as a fraction. So I'm going to turn 18 into a fraction by putting it over 1. And then you multiply across the top and you multiply across the bottom. So when I multiply across the top, I have 2 times 18, which is 36. And then I have 3 times 1, which is 3 on the bottom. Now this works out really nice because 36 divided by 3 is actually 12. And if you forget that, you could do the long division. So 36 divided by 3, 3 goes into 3 once. So 3 times 1 is 3, minus that is 0, bring down the 6. And then 3 goes into 6 2 times, and that's all going to come out even. Okay? All right, so if x equals 12, let's go ahead and plug that into the other equation. So 2 times 12 minus 3 is going to give me my final answer. 2 times 12 is 24. 24 minus 3 is 21. So our correct answer is A. Our third and final non-calculator question comes from the student-produced response section. So remember, this is the section in which you have to calculate your own answer and then put it into the grid-in part so that the machine can read your answer. Okay, so the question is, how many liters of a 25% saline solution must be added to 3 liters of a 10% saline solution to obtain a 15% saline solution? Okay, now I know that this looks really overwhelming. There's so much about like saline, like what is that? And then all these percentages. You know that there's probably an equation that has to be set up, but it might be hard to know where to start. Okay, I want to encourage you. This is a pretty standard textbook, quote unquote, question about a percentage of a solution. And so this kind of a question might show up in some form on your SAT. And if it does, there's a pretty straightforward way to approach it every time. Okay, so whenever you have 2 solutions or 2 liquids being added together to equal another one, we have to remember that if it's a solution, that means that there's actually 2 different things inside of it. So in the case of a saline solution, that means that it's water with some salt in it. Okay, so if it's a 25% saline solution, that means of all of the solution we've got, 25% of it is salt. Okay, so I'm going to draw a little diagram here. So basically I'm going to envision that I've got 2 little beakers here. Okay, and in the first one I've got my saline solution. Okay, I don't know how many liters of it I have, so I'm going to say X, but I do know that 25% of it, so I'm going to shade in the salt part of it, is salt. Okay, so if I wanted to figure out how much salt is in that first solution, I would have to figure out 25% of X. Now remember, you do percentages of by multiplying the percentage by the amount. So I can multiply 25%, which I would need as a decimal. So I move the decimal place over 2, that would be 0.25. So 0.25x would be the amount of salt in that first solution. Okay, they said it has to be added to 3 liters of 10% solution. So I know that in the second beaker, I've got 3 liters that I'm adding in here. And of that, 10% of that is salt. So if I wanted to know how much salt is in my second beaker, I would just need to multiply 10%, which would be 0.1, by 3, and that would give me how much salt I've got in that one. Okay, I could add these 2 together basically to get how much salt overall is in my system. And I do want to obtain a 15% saline solution. So I want this to equal a solution in which the amount of liquid I have is this liquid plus this liquid. So whatever X is plus 3 tells me how much liquid I have. And I want it to end up being 15% saline. So basically I want it to end up being that 15% of X plus 3 equals what I have here. Okay, ta-da, we have an equation. Now all we need to do is solve. Okay, so 0.25x, I'm going to leave like that. 0.1 times 3 is 0.3. Okay, this I would need to distribute out. Okay, so that's going to be 0.15x, and then 0.15 times 3. Okay, remember your multiplication. Let's do this off to the side. So 5 times 3 is 15, 3 times 1 is 3, plus 1 is 4, and then move the decimal place over 2 places. So that's going to be plus 0.45. Okay. All right, so let's move the 0.15 over. So I'm going to subtract 0.15x from both sides. Okay, when I do that, I'm going to get 0.1x plus 0.3 equals 0.45. Okay, I can subtract 0.3 from both sides. That gives me 0.1x equals 0.15. And then if I divide both sides by 0.1, now you might get a little confused on what the decimal does, so let's do that off to the side. So 0.15 divided by 0.1. When you do long division with decimals, you always had to move the decimal over in what you were dividing by, and then move it the same number over here. So 1 would go into 1.5, obviously 1.5 times. Okay, so x equals 1.5. And remember, x was our amount of solution in the first one, which is what they wanted. So there must be 1.5 liters of solution. Okay, so now that you have the correct answer, okay, don't forget to grid it in correctly. So your grid in question might look like this. You would need to put 1.5 at the top and then also fill in the corresponding circles. So there's 1.5. 1.5. Remember, they will also accept like equivalent forms. So if you really wanted to do fractions and you wanted to do 3/2, they would accept that. You can also shift this over one. You could have put 1.5 in the last 3 boxes, and they would have taken that as well, as long as you filled in the bubbles correctly.